Good morning. And good morning. Gonna jump right into it today. So, well, last night I had a lot of fun with Raspberry Pi. Got one of those, the new 8 gig boxes. Got NeoVim compiled on it, Rust Analyzer compiled on it, Rust setup, even compiled OBS on it, which was amazingly difficult. But not too bad. There were some copy and paste instructions I found online after a while. Let's see, so where are we going? We're going to go to here. Turns out that there was an easier way to avoid the capture of message in the closures from was it a day or two ago, and that you can stuff it into a message into an option, and then later just take elements out of it. And I think the way this is working is the scope ends up owning message. Excuse me, the option. So send here, this function owns message. And then what Toshi was saying was that these closures each take immutable borrow. So they take that of the option of whatever the message is. And so they're not actually taking ownership of it, they're just taking an exclusive borrow. And because their lifetimes don't overlap, it's okay. I'm going to definitely have to use this much, much more in the future. That is such a handy trick. I'm sure there's stuff over in Stream Multiplexer that could use this. All right. That's the downside of using closures. Yeah, that. Oh, you just ran into an issue like that. Oh, wow. All right, a little too early in the morning for this one for me. Man, let's get that one. Okay, so we got that. Let's see what's next. Well, that's right. We had been actually able to run Godot with our library. Everything's compiling pretty darn quick. That 46 seconds you might see over on the right there, that's actually not just 46 seconds for this. I had to change master. That match, if done with map and unwrap or else, extended the borrow of v. Oh, I see. So the match is required. Oh, wow. And is this something where you could have used like that little option trick, but it's ugly? I see. Yeah, this does look nice. Oops, let's see. What's that? Close that. Okay. Yeah, unfortunately, map here can actually return an error itself. So, because it is locking internally, so the map returns a result and not just you, it returns um, a result itself. Oh, I had questions on Rust compiling actually. So I've got a little Raspberry Pi set up, actually a couple of them now, and I was wondering if there is some sort of distributed compile system for them. Like if I set up a shared file system for them, could I get them to work together to build something? So I have Bob, is a Raspberry Pi. Oh, you're saying and this compiles? Obtuse and not using closures. Oh, I see, yeah. Yeah, the match is definitely nicer there. Oh, type inference on JSON. Oh, that's cool. Right. And then generate Rust from that. Oh, oh, that'd be handy. Oh, I've got a bunch of windows open here. Let me close everything to the right of this one. There. All ready for today there. Can't think of anything for Rust. Oh, that's too bad. Sometimes when I log in, it doesn't actually pick up the Rust environment. Oh, there it is. Why did that take so long? So I did set up SC cache, and this is on the Raspberry Pi. It's got a large disk in it. Um, but what I thought was interesting about this, and what I was trying to do, oh, it's not config. Cargo. Oh, I don't have bat yet. All right, let's open one more window. I want to compile bat on there. So at a global level, using the not vendor, the um, cargo config, set up the build wrapper here. I also, although this doesn't always seem to take, so I'm more relying on the environment variables for this. So at the bottom of my profile, it's tail. Just tossed a couple of these on there. In an attempt not to do anything. And then I was trying to vendor everything. And I don't know how successful that actually is. But it seems like if you go into one of the projects and do this, then it populates the vendor directory with what you have. And that works out okay. But then just using SC cache seems to work just fine. Let's say downloading. Give it another sec. Gonna get any cache hits on this? Oh, download all the crates. Yes, you're right. That might work. What can I do like the playground does? Just the top 1,000 or so? Alright, let's see. Did that pick it up? See, it didn't pick it up that time. Sometimes it does, sometimes it doesn't. I don't understand why. Stats are showing nothing. It's already there. Huh. Just grab one from the playground's cargo to Tamil. Yeah. Oops. It's not getting any hits. I don't know why. That should have the environment. Let's see, wrapper. Strange. Anyhow, we're gonna let that build. All right. Oh, what's this? Is this the, oh, that's a playground cargo to Tamil? How do they calculate what the top 1,000 are? Oh, that's the top crates from crates.io, right? Hey, Toggle Bit, how's it going? Hey, thanks for stopping in. All right. We're gonna go back over here. Oh yes, we had looked at the escape stuff yesterday. We got the escape bits working. In fact, status on this. Do that 10 times or whatever. Oh, you can just increase the per page, right? That's cool. which ones of these are we actually changing? Need to change legacies and these. Okay, let's get those committed. Yep, that's gone. Good. All right. You have every crate mirrored locally. You broke first. Test your plugin. Wow, that's impressive. Yeah, 10 gigs isn't all that much, but still, it's interesting. Wow. And did that help out? Or did you find that there were some things that, as you were going through crate after crate, that it would actually fail on? All right. So far, this is all working now, Museum. Um, we can now kind of send messages across from one to the other, from one thread to the other, and we couldn't do that before in this area. And some elements changed. This crate node assumes safe. That's different now. We can actually do stuff like this from the other thread. Sorry, I'll go back to that in a moment. So I was thinking I wanted to change this a touch. Oh, they have seem to be invalid names. Oh, wow. Some had typos. Truncations. Completely weird attempts at that field name in Tamil. I see. What's going to be the policy change? And how does Z standard break it? Oh, the version info here? Wow. Got it. Hmm. Well, at this point, we can start to try to get a login going. On login connect. See, I was going to have it connect and then do login, but I think login should be the connect command. about that. What? There we go. So we just get text off that. We get the type node there. Oh, I actually saw this last night. The GD native crate ends up relying upon this. Oh, interesting. Is it mostly the plus at the end? Plus blah? Not sure about this one though. I mean, it's obviously not a version number. Now, one thing that I saw recently in Godot was, or get node to figure out the version. Oh, you end up walking the string backwards to figure out the version. So node has this get path, and the get path, when it talks about it, it says that. Oh, no, that's not what I want. Get node. So you can actually refer to a property on an object as well with this. Get node and resource. If several nested resources are specified in the node path, the last one will be fetched. Okay. That's kind of interesting. Because really, I'm interested in the resource of this element. So if I wanted to get text off of there. I see, and the third one is the remaining, if any. I wonder if that works here. Because I'm just trying to get the text off of that. Let's see. Let. What am I doing? Is that an LCS on the tree? Is the way that'd work? Oh, and that's get type to node. Actually, we want. All right. Get node and resource. Get rid of that. All right, now get node and resource. I don't think that's going to be unsafe. Let's check. So the path, if it's like a DAG, it's the sequence. Yeah, it's easier to turn into a tree. I see, so we get a variant array back with shared. Well, a variant array, and it's going to be shared. It's not even an optional one. Oh, you can't index into a variant array? Really? Of get. Okay, yeah, index isn't there. Oh, let's try that. Oh, yeah. Wow. All right, and I wonder what that's actually going to be at this point. Because if we do get that, and it doesn't exist, let's say there's a typo, right? Somebody goes into Godot and misspells username or form, like I had from. Let's go ahead and do that. Let's see what that'll do. Search lets you do some interesting things. What? Or are you just saying starfoo? Oh. Oh, for return values. Oh, interesting. You know, I thought something would return I-64 at this point. That's pretty neat, though. Alright, there's that. Let's go wake up Godot. Let me wire it up real quick. Godot, Godot, Godot. Where are you, Godot? It just took it a moment. Okay. All things in standard library that return a VAC. Wow. Wow. That's neat. I'm gonna give this a run. You know what? I should have. Can't debug it that way. I have to start it properly. 99. Oh, that channel closed down. Okay, fine. Quick Godot for a moment. I have to start it up from a terminal. Let's say the path is going to be what? It'll be something like that. Oh, I'm in the wrong directory. CD source, legacy, there. Okay, that should start it up. Position is spelled wrong. Oh, did I? Oh, thank you. Thank you. I'm sure that confused me before. So I wanted it at a certain location and it didn't bother. All right. Is it loaded? Good. Okay. I ordered another monitor to make this easier. See how it goes. Okay, so we're going to go ahead and run that. Hit login. Now over here, we're looking for the result. I want to see what that ends up returning. So we have one that's going to be the good value, the good path. Another one that returns not the good path. Oh, get node. Node not found. So it just panics. Extensions 124. Why would that panic due to extension? Get type node, but I wasn't using type node. Oh, you realize something neat. All right, so and this is with type inference. Okay. So let mutable v equals a new vector. A is an option. I32 is none. B is I32. Sum 42. Okay. You're extending the vector with A and B. Oh, interesting. Oh, because it's an iterator, right? And when you extend a vector with an iterator, and it has, because an iterator of none doesn't do anything. Oh, that is neat. Hmm. Where is Pretzel? So why was get type node failing? Was it 5? Let's go to Rust. We can close that one. I thought it was crashing. Where'd the panic go? Yeah, that's something else entirely. Oh, I have 2 Godots open? Alright, this one can go away then. Okay, there we go. So we have login pressed, and we call get node for form error. Node not found, form error. Oh, that's absolutely right. Because we moved the script. It's not form error anymore. Wait, come on, slash form. Oh, there. Alright, I'm going to. That's the one I want purposefully not correct. Okay. Oh, good little test there. Let's close the game. Let's give that a run. Log in. Alright, we got some errors in here. Invalid node path, username, text. Interesting. It's neat that it tells us in here that that's not valid. So if we go back to login, let's see. Let's just log in. There we go. Username here has text. Do we have to use a capital T for that? like that it builds quick enough. You can iterate. Still 4 hours. Oh, it wasn't double, was it? It was just one? Okay, maybe it is lowercase text. Only one now. Oh, lovely. Okay, and so login 35 is nil, and 37. Now, why are they both nil? This one should be nil. This one shouldn't. Fancy. Okay. Let's just dump the whole thing. You're looking behind the curtain. Don't look behind the curtain. Let's start that again. Yeah, that's it's an artifact of the automatic API generation. Turning a null into an option T or default, depending on the infer type. Yeah, I wonder what that ends up in the API, because that's coming back as a variant array. Actually, let's toss another one of these open. Yes, everything's just a variant. Oh, that's strange. All right, give me 30 seconds. I need to check on something. There are turkeys wandering about. All right. So how would a variant know to which type it's supposed to be a no, none of? Actually, where are the accessors for this? Oh, there it is. The nil none does seem very non-rusty. I could totally implement index. What does index look like? Let's see. Associated type. Okay, so it's got an output for that, and then index here. I mean, how is that going to be different? I wonder if it could actually do that now. I mean, it could be that maybe index is only implemented for certain access. Yeah, this does not return borrow like index is going to want. Hmm. because that's going to be a local in this scope. So if we did try to implement index, here, let's just toss this on here for a moment. Pull index for, what is that, standard ops index. Where access is what? Probably, no. Thread access, probably. Yeah, so what goes in the generic type for index is the index type. I see. So what goes in the bracket? Well, let's go through it. Oh, wrong number. Did it try to do that? All right, Rust Analyzer is not being my bestest buddy at the moment. Implement missing members to enter. Come on. Oh, bogus. Okay. It doesn't have a generic lifetime. Oh, we need type, output, and that's going to be variant equals sign there. Expected one type parameter. Is that the U size? That's interesting. I hadn't noticed that before. All right, that's not used. I see, and then there's going to be no way to actually implement this. Because we wouldn't be able to get the local, right? So even if we got that, can't return a reference to it. It's the lifetime issues, right? Actually, let's just call the other one self-deck get. Hmm. because we don't actually have data to point to. There isn't a safe way of doing it. I see. Yeah. So all we have here is this pointer. Well, it has gotten better. Oh wow. That's great. I mean, not the nitpick, but what's up with the order? First thing I see here is that it's not alphabetic. Is it in the order that it's declared? Or the enum? I see. Oh, that's fair then. As long as it's predictable. Left column is ordered. Is it? I mean, it's shape. I don't see an order to it though, other than okay, left column matches enum. That's fine. Oops. All right, so yeah, we can't do the index for that because of that tidbit there. What would the unsafe way be? No, let's not do that. So I'm not sure why the resource isn't actually showing up here. Because I thought that node and resource should have given this to us. Get node or null. Single followed by an lowercase. Does it actually have to be of a resource type? So maybe it's not actually a resource. That's probably just it. There's something special about the actual resource type. Being able to sort tuples is something you'd really like. You have it ordered specifically so you can use partial order. Oh, got it. Yeah. It's pretty sweet though. Well, That's not going to work. We can't do that. Although I don't really care for the previous version of this. Like, this is so verbose. It is what it is though. Okay. That's there. We're going to use that in here. In net connect, probably. I mean, maybe, no. Okay, we'll just separate them. All right, if we get the error, we'll do that and then return. When in doubt, get text, node, yeah, path string. Yeah, I think that this will likely end up with a number of utility functions like that just to make it easier. Oh, that's right. And these aren't form. There. Actually, in this case, if let error, that's really what we want there. We're not ready to go to a different scene yet. Oh. Connect results for, oh, wait, okay, so after we've connected, can we do that? Oh, you can't put that on the block like that? Drat. Okay. So then next we send a message. The message is going to be the login. I've forgotten. What does that look like? That's a terrible name. Send? Message send? We're going to call net send, message send. It's gross. Bytes or data? All right, so we'll send something there. A couple things weird here in that if send fails, we don't know. I guess we do. We have a result. We could be looking at that result, which is, oh, yes. Should be able to send. That's so generic. Okay. And how does it fail? Fails when we can't get the lock, or documentation on this sort of thing is always, I've always struggled with it. And some people, they just do it so easily, and I want to try to get better at this. Um, so when I see send here, oh yeah. Yeah, why was it from? Is that from an earlier attempt here? Oh, because send core has it. Oh, because of this. When we do a channel send, um, we shouldn't need that into there, should we? Yeah, turning it back into the message. Lose the first M, lose the M in the first into here. Oh, I see. This is what we were looking at earlier, wasn't it? Yeah, it's not a concrete type. Okay. Let's say this will fail if Um, Send core fails, and send core fails when the channel is dead. Oops. Send message. It's actually it's a parking lot mutex. So this lock here for net. Let's see, where is it in here? Here. When you derive the class and need to do certain things on this class, because the script here is attached to an owner in the scene, and the owner in this case is the node here, and that just makes it available so that it can be plugged into the scene. Because net really doesn't care about a lot of this, but I'm trying to get away from using once cell in here, which is why that changed. How does it detect the lock being held? So that's actually over here in user data. And what happens, map. Wow, lots of little map functions in there. Oh, we want it on mutex data. There. So there are different kinds of maps. It defers to map mutable. And there is a deadlock policy here, which is why it's a little different than the other ones. Because you could have a deadlock policy where you say you allow deadlocks, or you're pessimistic, or you have some sort of timeout where you say, no, I want to fail if this attempts to lock fails within so much time. Yeah, I had to go look at that too. Because it looked so different from any other locking I had been used to. Yeah, the allow, of course, is never going to fail there, which is also interesting because actually, how would you set the locking policy on this? Let's say I did want it to have some sort of timeout, just for fun. User data, mutex data. What was that? That was here. I see. So I could specify an option there, and that would be deadlock policy. And I could say, oh, well, if you try to lock for more than 500 milliseconds or something like that, or 50 milliseconds or 5, whatever it is, something small, 100 milliseconds, because if it does do something funky there. I don't know what I'd do. I'm gonna leave it alone for now, but because I don't plan on having any deadlocks. This one, okay. I see, but I could actually set it here if I wanted. All right, so there's that. Why am I putting channels in our commutex? Why am I putting channels in our commutex? Yeah, that's a fine question, Eugene. Because you're right, they don't care. That was me doing a quick copy paste from the one cell. But I see what you're saying. Am I using Tokyo channels on this? Looks like it. Let's try it out. I think this, let's see, which ones are these? This is APS-C unbound center receiver. I don't think the receiver is. I don't think you can clone the receiver. But the sender definitely. Actually, and those are, see, where's this used? Is that, yeah, it's used way down there. Toss those there for now. I've been thinking of actually peeling the RX out of there and putting that into something else for dispatching events. Or use async channel, which doesn't have those. Huh. Async version of cross-screen channel. Oh, interesting. And is that from async standard? All right, self.tx on that. Yes, okay, and the bytes are long. Okay, leave that there for a moment. So if I'm going to log in, I'm going to send a message for logging in. Oh, is this a point where I need to start using the server serialization code? From the crossbeam guy? Oh, interesting. Huh. That's also the guy that did small, right? The small. Um, Not was it just small? Yeah, that guy. Oh, that's cool. All time recent. Oh my goodness. Where's the little graphs? I love this. It's like, and suddenly there it was. Oh, I wonder what's been changing though. Quick little aside. We're gonna go check that out. Releases, 19 tags. Tell us what your change log is. It replaced the executor in async standard? Really? Yeah, wow. The Stone Cold Man, thank you for the follow. Morning, Cat Peasant. I love that it's readable. Right, that's it. It's done. So it actually replaced it. That surprises me. Okay, wow. I have 1,500 lines of code, which is amazing. An async task, yeah. Hmm. Well, that surprises me about the internals of async standard getting swapped out. All right. Ooh, I got a little notification. 41 minutes ago. I thought that got merged, didn't it? Oh, awesome. All right, so I'll go over this later just to make sure. Mark is unread. There we go. We'll come back to that. If I want crossbeam like interface. Well, I mean, now that you say this, I'm wondering, should I go ahead and play around with like async standard um, instead of Tokyo stuff here? Very tempted to now. It's easy to swap it out. The channels, it's easy to swap out. Yeah, I'm eyeing small now. The bit I'd like to understand a little bit more is so I understand like in the client, this isn't going to be like a big performance impact for me. This is going to be much less active, right? Yeah, with small you have to set up the runtime manually, which is not hard to do here. But I wonder if I'm going to lose out on being able to use some of the other code that is probably using Tokyo that I would like to reuse. Oh, I understand it doesn't have a builder. I'd have to create the thread and basically have small in there. Small can use Tokyo. Oh, I can spawn a Tokyo runtime. Wait, let's go back a little bit. Kind of do want to play around with it. Hmm. Well, the piece that I would like to use here in this project is, and I don't think it's actually going to be dependent on Tokyo now that I think about it a little bit more, it's really the serialization parts. What am I using for login packet? And that's what I would like to use over here. I want the CBOR encoding pieces available here. Use a small token async standard in the same program. Oh, all right. Small uses futures async read async write. I see. So I want to get the codecs. Because I am using that. I think you remember my code better than I do. Yeah. So I just have to wrap in the right direction on the boundaries. Yeah. Oh, yeah. And you need to use it for Twitch chat. Oh, interesting. Hmm. Well, they're module. The length of the limited codec isn't all that crazy. I think that's all I'm using. And after you build it, builder, you get the encoder and decoder. But the builder here, it takes what? This is going to be the async read and write. Yeah, that's framed write, which then takes the async write here. It's actually a very small amount of code that I end up using out of there. Oh, it's so difficult. I would very much like to play with small, but I'm torn on like moving forward in the project. And let's see, you can easily convert futures async right to that. All right. Shall we jump into that rabbit hole? It's basically compare futures TCP stream, or let's see. All right. Depending on the type you're wrapping, you'll get the other traits. All right. Well, first things first. All right. Do I want to go down the rabbit hole with small with this? I think I do. And I think I'd be okay not using the Tokyo utils either. I mean, that's fairly straightforward to implement. We've implemented it 2 or 3 times already. So what's a 4th time? It's amazing how simple it is. You spend a lot of time writing your own. Huh, that's cool. All right, we're gonna go back to cargo. All right, there, that's going out. But I see what you're saying. I could probably use the Tokyo utils with the compat module with small and not have Tokyo at all, and still not have to write that code. Okay. All right, so and still use codecs, yeah, which would be nice. All right, we don't have runtime in here. What is runtime in this case? Runtime had been. It's not really a thread or anything, is it? Yeah, this is the DIY approach. Let's play with small. Okay. Kind of expecting that small is going to be easier on these other devices too. I don't know why, but it's small, you know, like maybe it's easier on a phone. I'd not have this pattern with small, with global runtime. That's okay. So I've not used small before. Reading the docs and looking at examples is a great way to get started. Learning async Rust. As long as I've set up the runtime in main, it'll work. Interesting. So where is main in this case? So when I call here, spawns a future, thread local executor. Okay. Panics if the current thread is not inside an invocation of run. I see. So Well, what I'm wondering here is, um, if there's a place that I should be setting this upstream. Right? We've played around a little bit with Godot Rust. There are a couple places in there we could do that, but man, needing the thread itself to be on there, that's different. Because I can't guarantee which thread is going to be calling into the Rust code. If Godot has multiple threads, it might actually invoke from either one of them, any one of them. Which is why I was kind of isolating with that one cell, as you pointed out there. Once, lets me define a function that'll only be called once. Yes. Except I don't store anything. I see. All right, let me see. How do we set this up? 3 executors that pull futures. Thread local, work stealing, and blocking. All right. Reactor. To wait for the next I/O event, the reactor calls epull on Linux, KQ on BSDs, and wepull on Windows. Wepull. It's Windows epull. It just sounds like so much more fun than the other ones. Wepull. Okay. Functions run simultaneously. This is mostly library to emulate epull on Windows. Oh, I see. That's funny. Okay, function run simultaneously runs thread local executor, runs a work stealing executor, and pulls the reactor for I/O events and timers. At least one thread has to be calling run in order for futures waiting on I/O and timers to get notified. Okay. If you want a multi-threaded runtime, just call run for multiple threads. All right. So in main, just set something up. That's nice. This function simultaneously runs that. Okay, so we just read that. Single-threaded, multi-threaded. I think we're just going to stick with the single-threaded one, which should be fine. So this is basically going to be pulling my net stuff. Multi-threaded. Stoppable. By default, it's unstoppable. Pending bits. All right, we'll go down there. Which will block run forever. Was it in futures? Futures future pending, or is that in small future pending? Oh, futures, futures. Oh, the pending future. Thank you. Sure, pending. There we go. I see. So that ends up returning one of these. Futures for the pending function. And it's always just pending, huh? Just never returns. Oh, that's neat. Okay, so let me come back to this. I want to go back to run for a moment. I see. So really, yeah, so using the channel to shut down and whatnot. So I get that. Now, because all I'm using for this for is actual networking, it seems like stuffing that into its own thread, right? Setting up a thread, stuffing it over there, and then just using channels to communicate with it seems like a fairly simple and straightforward way to do that. Oh, I see. I wouldn't be able to spawn like that. Oh, I don't need to even communicate with it. Task will do that for me? Really? Oh, I didn't. I thought task actually said spawn task also like features themselves. Okay. I thought it said I had to do that. Oh, I see. It spawns it into the work ceiling executor. Oh, I see. But I was looking at local, which will panic if it's not run inside of run. Oh, I see. Yeah, yeah. Wow. Okay. So yeah, it's just set it up and forget it, isn't it? Holy cow. All right, and in this case, spawns it into there. Maybe someone pulled by. Okay, pulled by any thread calling run. Okay. Wow. Yeah, we got blocking, cancel. Okay. Detach the task and let it keep running in the background. Oh, I imagine that's for one that was spawned locally or blocking. Expect. Detach is very important. Oh, interesting. So you spawn, then you detach it. Okay, expect. Spawns a new task and awaits and unwraps the result. Okay. Local, which we already looked at. You have to pull the tasks. Detach will pull it. And the work stealing queue. Okay. Hmm. Okay, and local and spawn, as we saw before, and then unwrap. Awaits and unwraps the result. Okay. Tokyo detaches and then gives you a handle. I see. Wow, this looks cool. All right, let's try that. Or was it getting called from? Runtime init. Okay, so where we plug in Godot, we're actually calling runtime init. Then we also have runtime reset, which we could shut it down with if we wanted. Smell gives you a handle, which you can consume, detach, or await cancel on it. But if you don't await detach, a task won't do any work, which makes sense. Okay. Let's say goodbye on that for a moment. Now for small, let's go back up here. Small task, or small. We just give it the future, and it could just be polling forever. So we use that. Wow. All right. I mean, we could do something async there. Whatever. But as you were saying before, if we always just await on pending, let's go look at the futures there. No, not that one. Futures pending. Just store a channel and send a message. Yeah, that's a good idea. We could actually use standard channels for this, couldn't we? Oh, I need an async channel. Oh, need to await on it. I see. Oh, that's right. Those aren't async. Doesn't Small have a way to wrap things like that? I guess probably not on this one. Okay. Small hitter. Oh, I see. It does it on its own thread. Ah. Okay. Wait, what was it? Async? That other one? Async channel? How big is it? It's tiny. All right, and what are the docs on this one? Docs. Async channel unbounded or bounded. I don't think we care in this case. Or shutdown. It can just be unbounded. For shutdown, you want it to be bounded. So the first call shuts it down, and the other block until it's done. That way you just need to read it once to end it. Otherwise you need to drain it before you block. Oh, I see. No, isn't this just like a bounded with one slot? Okay, I'm not seeing it. That's fine. It's bounded. All right. What? Bounded with one on there. Now the RX is going to be moved into here, right? And we'll do a RX.await. Init reset, reset init. The second reset will have one queued. Second which will. Hey, good morning, Ekton Dev. How are you? A month already? Wow. Oh my goodness. Oh yeah, we have to. Well, thank you for that. Bread in the banana bread in the oven? Oh my goodness. That sounds awesome. What is this? All right. It's slowly getting too ripe. Yes. Oh my goodness. Okay. So I have a semicolon there that should confirm type for T. Yes, that's fine because we don't have that yet. The type for T is unit, so we don't really care what it is. This with one cell is going to be interesting. Yeah, I don't. We could store it somewhere else, actually. We could attach this onto a node and make runtime an actual node. We do something like this. Oh, drive. Was it implement? Inherit. Or never. Two different conditionals. Well, I think we might be able to lean on Godot setting up and tearing this thing down if we go this route. Because instead of a singleton, we'll just have Godot attach it to the scene graph, and it'll be one of the auto loads. So that in which we can control the order of the auto loads with Godot. So if we come back in here, go to project bits. Yeah, I use ulti snippets, and so I've got a whole uh, load of these things like for tracing errors, info, whatever. Use GD stuff, little things that I find useful, and just toss in the bottom there. Or I can fill out common derives. Like here, if we do snippet, let's just say NAT for native script. I like 3-letter snippets. Also 2-letter and 5-letter snippets. Or maybe derive native or dnat, dnat. That's better. Oh, that's going to be awesome. All right, in this case. Native class, boom. Inherit node, which somebody could just do. There, we'll just, something like that. Close that. And then, oops. What was it? Derive Did it not? Well, oh, DNAT for derive. Okay, DERNAT. There we go. Yeah. So it fills out the correct standard derive somehow. If you do copy, it also does clone because, of course, oh, it's weird. Huh. You have dir and dirm as your snippets? What's the M for? Let's see, copy link address. Oh, wow. Ord, partial ord, equal. Wow. That is cool. All right, let's toss it in there. Struct RT, and we'll end up just, so that'll have the receiver in it. No, the sender, that'll have the TX in it. What is it on unbounded? This returns sender and receiver. So that's just async channel sender. Okay. Okay, receiver is just there. One of those. Sender receiver for both flavors, like crossbeam. Oh, that's nice. Oh, because the other one had it. Hey, Bearbot Gaming, how's it going? Thank you for the raid. Welcome. All right. Impl RT, and for this one, we have pub function. Is it just function new? No, pub function new. That's going to give us an owner, which we don't care about at the moment. Self. All right, and then instead of init here, we can move this up. Because we'll rely on Godot to build this out with us. Shutdown is going to be the TX side of it. All right, get rid of that. Reset should... Well, that's interesting. We can shut this down automatically using Godot, can't we? Because Godot has... Let's see, let's go back to, was it Node? It'd be faster for me to just search in Godot. So it has enter tree, and it also has the opposite of that, methods. Just probably like leave tree or get out of the tree. You're gonna hurt yourself. If you fall, you're gonna break your leg. Okay, where'd it go? Oh, the underscore one's at the top. Here we go. Exit tree, there it is. So if we implement that, then we'll get a call for that and can drop that. Oh, very cool. I am also going to copy that link of Museum snippets. All right. Thank you. We get rid of reset and init. Which also means we can get rid of spawn. All this code just gone. Okay, one cell, bye-bye. Oh, what's the task of the day over here? Got more chat going on than I'm used to. I'm missing stuff. Thank you for the at Mr. Halsey on there. The current task is to try to get small runtime working with in Godot. And it looks like it's actually going to be pretty slick. So using the small runtime, which is an async runtime for Rust, inside of the Godot Rust project inside of Godot. And what I'm expecting to happen is that when this node gets mounted inside of the scene, oops. Let's see if we can, whoa. Okay, I just broke everything with that, but that's okay. What'll end up happening if we go to Godot is that these auto loads, so I can control the order of them. So if I put the runtime at the very top, then that async framework will get loaded, it'll start running, and then I should be able to just spawn these async tasks from wherever. Should be great. Oh, you got an interview in the morning. Well, take care. Do well. All right. So back to the code. All right, so we're going to have this. Start small, there we go. Now we're going to implement exit tree. That's not it. Exit tree will take a self on that. Ignore to owner. Returns nothing. We have to export that. Can I export? Oh, we need methods. There we go. Oh, we want to try send here? Try receive, try... Is that on there? Async, sender. Try send, yes. Interesting. Try send unit. And let's see, it has a result or an error. Channels full or closed, then it's done, which is okay. I think we can ignore that. Well, let's be a little bit more aggressive about it. self.shutdown. That good. Oh, if I store the join handle. Oh, for the run here? Oh, I'm supposed to store. Gotta create a thread. Oh, where is that? Standard thread. A thread spawn. I think. Let's see. Functions. Panicking. Oh, that's neat. See, they also have a builder. You know me. I like my named threads. That's what you do. But your flow is to initialize a pool in main. Do stuff and then wait for the pool to join all of the internal threads. Copy link address. I see. And then you have size just be whatever you want. I see. Oh, that's neat. All right. Yeah, that's handy. Join handle is standard thread join handle. Good. There's nothing to do there. Actually, I'm going to be using a thread builder. You don't go for the name of threads, huh? Oh, I see. So in this case, you're dropping that. Oh, of course. Because you don't even have to send the message. You just drop the channel and the other side closes. Rad. Let's see, what is this? This is async runtime. Don't panic, you don't need to see their names. That's right. That's right. Let's see, for this, we could do one of those. Oops. Need to unwrap that. That's more of a Godot expect, I think. Stack size is too big, too small. The OS doesn't support native threads. Which operating systems don't support named threads? I think Android, iOS, Windows, Mac, Linux. I guess embedded things wouldn't, or potentially wouldn't. How often do you use hardware that doesn't support named threads? Okay. But the stack size then, that could be an issue. All right, and then in this case, in the exit tree, let's see, this isn't really a destructor, so we can't take self, we can't own self. Could have that an option. Use that little fancy trick we learned. Then we should get notified if we enter and exit the tree again. WASM is the obvious thing. Oh, does WASM not have named threads? Doesn't WASM threads get converted into workers? Worker threads? Oh, not yet. Oh, interesting. I like that pattern. This pattern better, where you just drop it. Don't even have to send the message, which is wonderful. What was it? Join. We need to join the join handle. Self dot join handle dot join. I don't know what to say here. Async runtime issue. Oh, I see. It returns error if it panicked. Waits for the associated thread to finish. If it panics, error is returned with the parameter given. Okay, which is highly unlikely in this case. Unless there's something going on with small. Maybe small could panic somewhere. This is unlikely to panic. All right, let's start at the beginning. Because we have that, we don't need to use these anymore. Because now that'll just get added and removed from the scene graph, which will be great. Okay, it also means that we just use gdnative init. That BTTF reference was too forced. Yes. Did why is that chicken running? Oh, we must have eagles right now. Yeah, when you see chickens running for cover, it's usually some predatory bird up there. All right. Login in net. Okay, let's go look at login first. Futures RS logo is actually BTDF. Really? Wait. Where was it? Oh, we gotta go over here, don't we? Oh, yes. It's obvious now that you say it. All right, Tokyo one shot's gone. Oh, I like one shot though. Well, that's going to change this because now we can just do small spawn. Go to the other end of this. We have to detach it. No spawn on small. Oh, one task over. Functions. Oh, task spawn. Macro struct. It was in task. Thank you. All right. Oh, I'm gonna miss the one-shot channels. Interesting though. I wonder if this means that I can actually await on send. Send core. Send core does this here. Oh, that changes everything. Hold on. I'm just going to take that off for a moment and play around with some stuff. Bounty of 1, yeah. Arn, good morning. Arn 4VV, how are you? Async tube is pretty neat. The way that the small async works is pretty clever. Okay. Basically, it implements async read write for an arc, mutex. If the T is also implemented. Oh, interesting. Okay. So what do we do here? We create a new one of these, connection none. Disconnect. How do we use this? Okay, yeah, we got some async stuff here. Here we have net. Net ends up getting this little spawn loop thing set up, which is going to be different now. So in this case, we're just going to use task spawn. Small task spawn, async move on that. Detach on that. Which will have a different kind. Let's see, does that give us a join handle? It doesn't, does it? And our select is going to be different. Okay. You don't have to go call lock or anything. It just does it internally. You can keep that abstracted. Oh, wow. Small doesn't have a select, and future select is dumb. Yeah. Detach moves to join. Okay. All right, we'll just do that. It's okay. I don't have to keep hold of that. It was actually kind of not being used in the first place. All right. You're well. Good. Good. I'm glad to hear that. You've never tried learning Rust or other compiled languages. They look intimidating compared to interpreted languages. They're just different. Rust has a couple different concerns than a lot of interpreted languages. In fact, I'm having trouble thinking of an interpreted language that has ownership tracked like Rust does. Um, all right, we don't need runtime anymore. I would suggest trying it out. There's a lot of different languages out there. Rust is my favorite thus far. That way it runs in the background and notifies when it's done over the channel. Oh, I see. Yeah, the old Tokyo one-shot idiom. That's fair. All right, so we'll get there in a moment. Bytes, we have that. What are we missing? Use async channel. What? Probably. Well, self for now. Oh, we wanted bounded channel. Probably. I don't know. This is just going to take like a whole queue of channels and things. Unbounded. TCP stream is gone. So that's just going to be from standard, isn't it? Or it's just, yeah, standard net TCP stream? Wow. So we have a new uplink. Why do we have a new uplink? What uses uplink? Oops, spelled that wrong. There we go. Oh, this is in spawn link, a spawn loop for net. I see, so net uses it in the spawn loop. And net's just kind of like this little fancy wrapper around it. I don't know if we need that thing anymore. So if we use unbounded, spawn loop, handle's gone. Okay. And this is just going to be sender, which is so nice. And what's an IO result in this case? This was from Tokyo, wasn't it? Tokyo IO result. That we're not using the TX here, are we? Why is it even being passed in? Oh, because it will eventually be used. I don't know. I'm just gonna rename that as channel. Okay. Oh, we need a sender and receiver as well. Oh, it's wrong syntax. Selfish channel. Oh, thank you. Actually, that is much nicer. Yeah, I wanted unbounded as. Oh, no, no, no. Actually, this I think is the pattern I wanted. I wanted a channel. I wanted to show channel unbounded so that people would have um, context instead of it just saying unbounded. Well, what is unbounded? I wanted to know what was unbounded. Man, I have found, just a quick aside, it just came to mind. I have found Rust to be such a humbling experience. I'm pretty good at web stuff. And I found that getting back into compiled languages, like I've been doing Erlang and some other stuff, but getting into this stuff, there are so many more patterns that are available. And just even this, let's see where to go. Is it still open? Oh, here, type state pattern in Rust. Oh my goodness, this thing is kicking me hard. I'm going through and trying to learn this. Um, and then watching some people just get it so easily. I have to try. I don't. I think it's just been because I've not been exposed to these things for so long that I've lost that edge on it. But it's nice getting back into Rust and getting challenged again, kind of mentally. I've been a little bored. So it's been good. Type space in Rust is ugly. Oh, sure, compared to Haskell and Scala, but it can do it, right? And that's actually one thing that Godot Rust is doing to help with um, kind of the wrapped safety issues. HKTs, a lot of extra syntax for no reason. Rust has been good. I've really been enjoying Rust. It's not as terse as Haskell. All right, so in this case, we're matching on the connection. What? Oh, it's either going to be some or none, and in this case, we're going to have some funky, just random IO error. I see. Is that... We have our IO error here, and for its kind, does it support the exact same thing? Yeah. Okay, it must have just been... Why is Vim not working? There we go. There we go. You were reading through the compiler that came before Haxi? I used Haxi for, I don't know, a year maybe. It was a compiler for AS2, which became the Neko VM, which was recently replaced by the Hashlink VM in Haxi. Oh, interesting. Infini, thank you for the follow. Yeah, that, I think the AS2 compiler, didn't they also do AS3 in Haxi? Trying to remember, but I think they did, because there was ActionScript in AS2, and AS2 was still kind of blah. AS3 had a lot of the kind of new fancy syntax. Maybe it was AS2 that I ended up using for that project. We made some really awesome stuff on it. It was kind of an experimental project. MTask, yes! Oh, I remember that. Oh my goodness. It was like me in 2006. Wow. And the parser? Looks like BNF syntax. Yeah, I don't know how to parse this. Each and is a different pattern, I see. Parse inherits this, parse inherits, I see, parser. Parse flags. Dynamic or intrinsic, I see. It's difficult to do in Rust because of the mutable self. Macro it out? Oh, you can't do that. Just a moment, I'm replying to my wife. All right. All right. Yeah, that's right. We're working on send. Okay. We have these two types here, which are absolutely wrong. Actually, and why is IO result not in the scope? I thought I brought that in. Oh, I brought in IO error. I see. There we go. A little bit more. And error kind. Okay. All right. So at this point, we have a connection. What is our connection? Self-connection at this point is a TCP stream. Okay. Now, if we're trying to make this async and write to that connection, oh, that square bracket foo syntax is a type constructor? You can see Rust in there if you squint. Returns. Oh, I see. Oh my goodness. Is this a lifetime? They don't do lifetimes, do they? What is the single quote mean here? I got some in my eye. Ugh. Oh, shadowed binding. Oh, they have that in Elixir. Because you can't shadow stuff. Ah, I see. Actually, they have what? Pinning in Elixir? It uses the same style of syntax, but it's different than that. Because I don't think it's quite shadowed. All right, so let's go to small again. Actually, I wanted to get to the docs, which had been won over. It's not there anymore. Oh, there it is. This type converts blocking IO types into async types, provided it supports equal KQ. Okay. IO operations can be asyncified by methods with. Do not use this type with file standard. Okay, because they're not supported. Use reader and writer for that. Nice. Codebase is 15 years old. Yes. Oh, I see. That's a list like a slice. Huh. Interesting that they have all of these functions defined. When is accept actually implemented? UDS stream? Oh, Unix status. Okay. Oh, interesting. Okay. Let's look at width and width mutable. Ah, didn't go down there. Where is width? It's not actually defined in here. Oh, that's strange. Write width and read width. Oh, that was the name a bit ago. Oh, I see. Okay, so going back up to the top, I get that this is a little bit out of date. Does that mean we also have to split those? The two functions you give it closure and call every time it happens. So here we create a TCP stream. Oh. Oh, I see. Oh, that's neat. I think you showed me this before. If a type does, but its reference doesn't implement async read and write, wrap it in Piper's mutex. Got it. Okay. So we just say it's an async TCP stream. Wow. Okay, so let's fix that up above. Let's pull that in from small. Task and async. There. So we have our async there. Self new connection none because it's not set up yet. Self.connect. That's on self. Oh, connect. I want connect. Yeah, address 8. Oh, wow. And that returns a TCP stream. It actually doesn't need. Wow. Okay. Oh, one too many angle brackets there. You can split them. Futures can. But they recommend using async to. Okay. Which will let you clone as many times as you want. You can read write to any of those clones. Oh wow. Okay, that's different. That's nice. Oh my goodness. No way. Oh, my wife made blueberry scones. Oh, that's not fair. All right, so this is async. We have that'll panic if we try to do that twice. Actually, what I'm thinking about here is stream multiplexer. How stream multiplexer would be different if that didn't need to be split. There was a lot of stuff that happened in stream multiplexer that could be simplified because of that. This exploration with small might devolve into like a benchmarking of small with stream multiplexer versus Tokyo and stream multiplexer. Let's see what it can do. I mean, how's it perform? Like, are people comparing it in terms of like a networking performance to Tokyo? How's it hold up? All right, and this just drops. I don't think we have to do anything for this, do we? Take or else, yeah. Okay, that just drops the connection. Basically the same levels. Wow. Man, I love Tokyo. Tokyo was like my first async love. That is like that on Windows though? I see. Well, I think for, like in my case, it's not going to matter because most of the game clients aren't going to notice that overhead. It's not like I'm creating some ultra high performant networking game, but I can see in other cases it could be an issue. Just looking at the weepull code, got it. All right, this is just going to be a sender and receiver. Oh, well, let's just get rid of those. Call that receiver. Call that one sender. Okay, delete those. Oh no, this is for the net. Technically, I don't need that right now. Where's RX come from? Oh, RX is up above. I see. Wait, what am I doing? Hopefully the exploration of boats ringbound will drive future. Oh, interesting. Future slash pin forward. The current model doesn't really work too well. Oh, receiver impulse stream, by the way. You know, while that loop over it. Ah, all right. Wildlet message. Wildlet. Oh, this is OK message, isn't it? Or some message. I forget. One more of those. Good. Oh, it's some. Thank you. Result, result. What? Because of the stream EXT. Right, now that's not in scope. Yeah. Let's see, I don't have futures in here. All right, where is utils? Alec, block, config, compat, standard. Async await and standard are the only important things. Wow. Oh, I see, and that brings in futures util here. And what was it again in? Oh, I see. Oh, what was it? Async. Oh, wait. Using it, you know where I have the new what features? Actually, where I spent my off hours last night on Bob. Bob has the new one. I mean, look at that. It's beautiful. Actually, that one doesn't have anything. GD native. Look at that. I like the colors. Are these colors from that 20 colors page? No? Oh. All right. We'll give that a little upgrade there. What was this one? It's just, that's strange. Okay. All right. So now in this case, what do we have? We have connection, whose type should be known. TCP stream. Oh, is there not a write all on this? It's writable. Async read, async. Oh, they're randomly dragging sliders around MFA. It's very small. All right. And where is that? That's features docs. Futures IO. Okay. Use futures IO. Sync write ext. All right. So write all now passes. Oh, awesome. Disconnect is not async. That's fine. Now we have our net bit here. So next returns option is self item. Why is it doubled up? IO result of message. Is that because, so we call next, that returns an option. Oh, no need to worry about clashing with Tokyo. Yes. Oh, item is a result, so option result T. Set a marker. That should be both of those, shouldn't it? Oh, item is a result. Okay, so that's a result. But so option result T, but I'm getting this doubled up. So here, message is still a result, even though we've decomposed it here or destructured it. But I don't think that's true. I think it has to be some. Okay, for some reason. But yeah, that's a good call on that. Oh. Strange. Okay. And the only reason that this would fail is because the other side was closed. Yep, and the loop would stop. Oh, that's great. That's really cool. All right, and I think I'm going to do just another task spawn for the sender eventually. I'll just be right there. Ahead, Pete. Thank you for the follow. All right, so send core. Oh, did I change those yet? Oh, okay. Mismatch types, expected result. Oh, is this because of the return value? Send dot, oh wait. And probably same thing here. Send core. I'll wait on that. It's only allowed in async blocks, and async probably isn't allowed in that. Uh, Small block on, turns async to sync, but then it's yeah. Wouldn't that mean that this code here, the send, would be blocking and not async? Yeah. Hmm. All right, I'll have to play around with that later. We've made a lot of progress on this. I really like small. Small's pretty cool. In fact, I might spend my lunch hour reading through the source code of it. I think that'd be cool. Get to know it a bit better. 1,500 lines. It's hardly anything. All right, I gotta get running. See, is Adam still doing like interview prep? Yeah, probably. Trisend is a non-blocking send of the channel. I see. So there's a possibility that I could just actually real quick. Let's jump back over there. Sync channel. Docs. There it is. It'll block until there's room. I see, and I'm using unbounded channels, so there's infinite amount of room. I see. So there really isn't any point to me making that async because I should just be using trisend instead. Oh, okay. But if you're using an unbound channel, is there really a performance difference between these? It's probably just some atomics and queuing something and then I'm backing out either way, right? But this one here will wait until there's room. Okay. All right. Well, I gotta get going. Nobody good to raid. Anybody have any suggestions? Send can be combined with other features because it's async. Oh, I see. Yeah, that'd be good. Send won't error if the... Okay. It'll yield until this room. But you can also time out, which makes sense. Yeah, but you wouldn't... Yeah, and because I'm using an unbounded channel, I don't really need waiting for the room or waiting for it to time out. It's really just the combinators that would be missing. All right. I'm going to head out, y'all. So, let's see. Yeah, the same sender is used for both of them. And I get that. It makes a really nice API. You know, I think this game might be doing Rust. We'll see. But I think the language might not be English. It's concurrent queue, the same idea. I see. I haven't browsed like science and tech live channels for a while. Is let's say programming. Let's give it a scroll. No. What about Godot? Still just me. Oh, Raimu just went live. Oh, Raimu. We're gonna raid Raimu. All right, back to the code. I'm having a hard time with this today. Then I got scones and coffee waiting. There we go. Well, thank you all for hanging out, and thank you for the help with small and all that. Small looks really, really promising. Looks pretty amazing, actually. It's beyond promising. All right. Till next time. Bye, y'all.